Question 3. A researcher was to compare the average amount of time spent on extracurricular activities by high school students in a large suburban school district with the average time spent on extracurricular activities by high school students in a large city school district. The researcher obtained a random sample of 60 high school students in a suburban district and a mean time spent on extracurricular activities per week to be 6 hours. So that's going to be your mean of the high school. So I'll just do X bar 1 and a standard deviation of 3 hours, so S1. We also have the researcher also obtained a random sample of 40 high school students in the city school district. So that's going to be our sample size, 40 high school students. So we'll say N2. This is going to be N1, by the way. So N2, 40, and found that the mean time spent on extracurricular activities to be 5 hours. So X bar 2 with a standard deviation, S2, of 2 hours. Suppose that the researchers decides to carry out a significance test of HO, suburban equals city, versus a two-sided alternative. Which of the following is the correct test statistic? So we need to know the structure of a test statistic. Let's recall our formula sheet. I'm going to pull this formula up from the digital version so you can see. It's going to be right here, the statistic minus parameter over standard error of the statistic. And we're going to go ahead and write that down and fill the things we have. It's worth to point out that you also have to pull the standard error formula down if you want to know how to utilize this formula. Although they kind of have the same structure, so we can maybe get away with just kind of remembering what it looks like. But because this is two samples, we're going to want to pull from this one. So you can see you have this formula right here for two sample means, and you can see it has a s squared over n, s squared over n. So we know it's going to be a number squared over n. You see how this one right here doesn't fit that, and it doesn't have a square root over it. This one doesn't have the number squared over the sample size. This is just the standard deviations. So those are no good. And we can also kind of rule out this one here. So we really only have two possible ones that would even kind of make sense. And you just got to remember that because we don't have known standard deviations, that this is going to be a t test statistic, not a z. So we're not going to do a z statistic when we're talking about means. Anytime we're talking about means, we use t. So we really don't need to be able to calculate this. We just have to know what we're dealing with. So it's going to be the statistic is the difference of the two means. So it's going to be x1 bar, x bar 1 minus x2, x bar 2, minus the null parameter, which is 0, because there is no difference, divided by the standard error, which is the square root of the sample standard deviations squared. So we have 3 for one, and we have 2 for the other. So 3 squared over the sample sizes. So each sample size is 60 and 40. We want to make sure we have the right ones together. So it's 3 squared over 60 and 2 squared over 40. And technology can't, I mean, you can do the two sample t test in your calculator and get the value of the decimal, but then you'd have to go back and plug them in, which may be a little bit of work. So just looking at the structure of how that's set up, we can see that our answer is going to be E. So remember, T is means. And so look for those gimmies and try to get rid of any ones that are going to be easily to eliminate for your answer choices.